Use algebra to find limits. In this lesson, we're going to learn to use algebra to find limits. So what we want is to find the limit as x approaches a f of x. So far, what we did was we tried to understand the concept of limit using graphs, and also we found limit using table of values. That is also to help us to understand the concept of limit. But if actually we want to find limit, we should first try to substitute the value of x. X approaches a, mean we going to substitute x equals to a and then see what we get. If we get something like 0 over 0, which is called undeterminate form, or any other undeterminate form, then we should try to simplify the function f of x using algebra and then get the limit. That's how we're going to do it. Now, before we learn to use algebra to find limits, let's talk about direct substitution property. Suppose we want to find the limit x goes to a f of x. Now, if f is a polynomial or rational function and a is in the domain of f, then limit x approaches a f of x is same as f of a. Mean we directly substitute the value of x as a in the function over here. So that's what the name direct substitution property. Now in this example, we want to find limit x approaches 5 x squared plus 2x minus 10. Now this is a polynomial function, a quadratic function. So which is domain is all real numbers. So therefore we can just substitute the value of 5 here. So what we get when x goes 5, we get 5 squared plus 2 times 5 minus 10. So we get here 5 squared is 25 plus 2 times 5 is 10 minus 10. So that will give you 25. And in this problem, we want to find limit x approaches 1 of this function. As you see, this is a rational function. And the denominator is going to be 0 when x equal to negative 1. That means the domain of this function, domain is all x except x is negative 1, except x equal to negative 1. Now we want to find as x approaches 1. So therefore 1 is in the domain. So we can use direct substitution here. We get 1 squared, which is 1, plus 3 times 1 minus 1 over 1 plus 1, 1 plus 1. So that gives us 1 plus 3 minus 1, which is 3, over 1 plus 1, which is 2. Find limit. Example 1. Limit x approaches 3, x squared minus 9 over x minus 3. Now we can see this is a rational function. The domain is all real numbers except 3. So we want to find the limit as x approaches 3. So this we cannot use direct substitution. Now if we use the direct substitution, using the limit rule, the limit x approaches 3 of the numerator will give us 3 to the second minus 9 over 3 minus 3. As you see here, this is actually 0 divided by 0. So in that situation, we should try to simplify. Now here, the simplification is easier. As you see here, we have x squared minus 9. So the factors of x squared minus 9 is, if you can remember, the factors of a squared minus b squared, which is a minus b times a plus b. So this is equal to limit x approaches 3, x minus 3 times x plus 3 over x minus 3. Now x approaches 3 means x is not going to be 3. That means this is never going to be 0. So therefore we can cancel this x minus 3. Now what we have is limit x approaches 3, x plus 3. Now as x approaches 3, x plus 3 will approach 3 plus 3 or a 6. Example 2. Limit x approaches 5, x squared minus 6x plus 5 over x minus 5. Now the domain of this rational function is everything except 5. So the 5 is not in the domain. So we cannot use direct substitution. So we should think about simplifying this. Now even if you do direct substitution, you're going to see you will get a 0 divided by 0. Now denominator has x minus 5. So if we can simplify this, the only way we can do is if we have x minus 5 as a factor in the numerator. Now the factors of this quadratic expression, we need to find the factors of 5 which will add up to negative 6. So that will be x minus 5 and x minus 1. So clearly x minus 5 cancel out. We get limit as x approaches 5, x minus 1. So as x approaches 5, this will approach 5 minus 1, which is equal to 4. Example number 3. Limit x approaches 0, 5x to the 5th plus 4x squared over 2x squared plus 3x to the 3rd. Now clearly, if you substitute the value of 0 here, you get the 0 plus 0 in the numerator. And again 0 plus 0 in the denominator, which is 0 over 0. Now we need to try to simplify. Now if you look at here carefully, and in the numerator x squared is a common to both terms, so you can factor out x squared. So we get 5x to the 3rd plus 4, and the denominator also x squared is common, and then we get 2 plus and 3x. Now clearly x squared cancel out, so this is equal to limit x approaches 0, 5x to the 3rd plus 4 over 2 plus 3x. Now we can do the direct substitution over here, or we use the limit rule. So limit of numerator, we get 5 times 0 plus 4 over limit of denominator, we get 2 plus 3 times 0. So what we get is 4 over 2, which is equal to 2. Example 4. Limit h goes to 0, 2 plus h squared minus 4 over h. This is also a rational function. As you see here, the denominator equal to 0 when h equal to 0. So clearly 0 is not in the domain. So we cannot use direct substitution. Now we should think about simplify. And it is here first we have to expand this one. So if you can remember a plus b squared, we have 3 terms. A squared plus 2 times a times b plus b squared. So we can simplify over here. We get limit h goes to 0, 2 squared 4 plus 2 times h, which is 4h plus h squared, and minus 4 over h. Now clearly If 4 cancel out, what we have is limit h approaches 0 4h plus h squared over h. Now you can see in the numerator h is common, so we can factor it out. So this is equal to limit h goes to 0, you get h out, you get 4 plus h over h. So again h cancel out, so we get limit h goes to 0, 4 plus h. As h approach 0, we get 4 plus h approach 4 plus 0 or 4.